Hey guys, welcome to the Flat Lab.
Special edition science project show.
Yep, Mark and Trish Carew here, Flat Boys, and we have Alex with us tonight, as well as Abby and Will. And Alex has a special science experiment that he wants to work on. Come on in and tell us about it, Alex.
Okay.
Hello.
Oh.
Say hi.
Hello, people. Well, mostly the project is about, it was weather fair, so we had to come up with some type of weather. They gave us a list of different types of weather, and me and my partner chose earthquakes. So we had many ideas on what the earthquake thing was going to be about, and my mom also looked online for other ideas, but my Uncle Mark told me that he still has his earthquake machine that he had for his earthquake contest.
Yep, you guys might have remembered we had the Flat Quake contest where we had the foam building, and we had a lot of you guys supported designs for different suppression systems to go under the building, and we had the flat Kong on top, and we would shake it. That was a really cool show, and when Alex knew about the earthquake machine, he was like, well, let's use that. So tonight we were thinking we would design some buildings and try to create an earthquake scenario for Alex's project. And we don't know exactly what we're going to do yet. It might be that one large building, or it may be several buildings. It's all what Alex is wanting to do with it.
And what'll work best in the classroom.
And we're also going to pull some opinions from Abby. Come on in, Abby. Act normal, Abby. and Will, a.k.a. the Purple Nurple.
You learned that the hard way.
So we're just going to sit around. We're going to talk about what we can do for the buildings. And we're also going to bring the machine over and see. I actually modified it a little bit. We made it a little stronger than it was last time. So we added a little more to the counterweight system. So we're going to go through and actually, I'm going to get an extension cord for this, but we're going to go through and see if we can come up with a way to ensure that the buildings fall over, right? Is that what you're after, or do you have any other?
Yeah, mostly I want to make sure not if we put it on minimum, not all the buildings fall.
Right.
So it doesn't all fall as soon as you turn on.
That's right. Okay.
Only a few fall down.
So you want to get it to a point to where you can slowly crank it up and then they fall down.
Yes.
And do you want to do multiple buildings or just one building?
I've actually chosen to do multiple buildings.
You would. Just kidding. No, that's fine. We could do the multiple buildings. What we need to find is an extension cord, guys. I don't know why.
A regular extension cord?
I think it's on the shelf.
It's out with our lights.
Oh, it is?
Mm-hmm.
Okay, can somebody grab that?
Sure.
I'll get it.
No, Will, you.
You're taller, Will.
Where? I could have got it.
On the umbrella on the table where the lights are, you'll see it hanging down. It's brown. It's folded up.
So, in the meantime, I'll also get SketchUp pulled up over here.
All right. So what I was thinking with this piece of foam, can you hold that? Thank you.
As a test bed?
As a test, so we can see what different size buildings. What we'll put this on here, we'll turn it on, and we'll see what it looks like, and then we can cut it down shorter and shorter, and you can see what the best height is.
Or actually, that's a good idea. Or we can actually bring it in tighter and tighter. Here's the problem. Thanks, Abby.
All right.
The problem is, if the stance is so wide, he doesn't have any kind of suppression system or anything on here. So it might just dance off to the side. But if we lessen the stance, I think, and make the buildings tall enough, we have a good possibility that they'll tilt, right? Isn't that what you guys think? If you make the bottom of the building smaller, it'd be like a pencil trying to stand on here.
You listening, Alex?
Yes, sort of. Maybe. Insert.
Let me see. Yeah, that has to be cut off there. Where's the
That's our good extension cord, man.
No, that's just a ground block.
Second there.
Okay, so go ahead, Alex. Remember, you want to use variable
V8 on.
And if you look under here on your side, you should see it
Look under us.
slowly moving. And then you have to give it time for it to catch up. And then once it reaches a maximum speed at that level, you can slowly turn up a little bit. Then you have to wait again. Takes a little while for the energy from that counterweight to transfer out.
Alright, I turned it up a notch.
There, Mommy.
You need to look under there too to see if it's spinning faster than it's moving. You know what I mean? There she goes. Now see, that's already a really good amount of sway for an earthquake.
Yeah, but as you see, it's kind of what you said. It's kind of drifting off, not really tipping.
All right, so let's do this. Where are you at? Okay, let's turn that back off. Okay, and we'll make this smaller.
Smaller, like skinnier?
Yep. And we'll find the optimal size
That's what we need smaller.
base.
You think probably that's what we should go for now? That's smaller, right?
That's a little smaller, yeah. I think we need to go get smaller than that. Can you hold that in real quick? Here, let's go over here. I'll roll it. Something like.
You could make some that are weaker and some that are like tougher.
True.
Now, are you saying we should have ones that break away? Well, please stop. Are you saying we should have ones that break away?
Well, that was our first original idea, that the buildings would break apart, so we just put it back up. But once I thought about it more, that it would be really hard to get all the pieces back and put them back just for the next person that comes. So
Okay, variable.
one song, right? One variable.
Yeah, that would be. How many people are going to be viewing this project?
I'm not sure. Like
Pretty much the
most of
whole
the
6th
grades,
grade and some parents.
Like
How many people do you think that is?
Well, 5th, 6th grade, and 5th and 6th grade classes, and a couple of parents. I invited you as well.
A lot.
A lot? Like 100?
There's a lot of 5th and 6th
Wait, what?
graders.
100, you think?
I'm turning it up a
I
notch.
don't know.
Alright.
Alright,
Okay, now take a look at the top of the building. It's already starting to wobble. See it?
getting it.
Okay,
That's-
That's already a good.
that's
shot.
really good.
This is below what we had before.
You should use that
Okay,
shit
turn
on
up
it.
another notch.
This is what we had.
Doing pretty good already.
Yeah, that's an earthquake right there. That's quaking.
That looks like a building in an earthquake, doesn't it?
Yeah.
Rocking around.
Yeah. It doesn't even have to fall.
So we could even go with buildings that are even smaller than this to guarantee that you don't have to turn up. Go up it some more, Alex. Let's see what we got. See if it can fall over.
We'll eventually fall over.
It's doing a good job. Standing up even. Uh-oh.
Oh,
See, it just takes that right combination and it'll knock it over, you know?
get ready to fall over. That's what it
Let's go up another notch, Alex. Whoa, that's a big notch.
Oh no.
It's really shaking now.
Oh no.
Stay on target. And another thing we can do, which I forgot about, is we could add weight to the top.
What would that do?
That would instantly guarantee that it would fall over.
Yeah.
All
Instead
this-
of
That would work out?
That's
Let's
kind
try
of
that.
also wrong.
Let's hit off, and when you hit off,
What'd you
make
say,
sure
Will?
you lower the
I don't know.
the speed back down too, Alex. All right, let's add some weight to the top. Where's that washer you
What
had
kind of
earlier,
weight?
Will?
What kind of
On
weight
the
should we
washer?
use?
He had one of the
Will
things
had a
we hang on.
washer.
Spring?
There it is.
The things
We'll
we-
tape that to it. Mhm.
Yeah. We told Will to hang
Just
on.
anything, really. Just
This tape or that tape?
I'm just gonna tape it on because it's not a big deal. I'm just gonna tape it to the top.
Now we have a little added weight.
Yeah, let's see what
You
this.
don't need much weight for paper.
Yeah. Okay,
Foam.
let's try it again.
Still,
Alright.
it's pretty much as light as paper.
Now this time, take your time working your way up because
Didn't start yet. Oh,
is it
it's
moving?
A little.
A little bit now.
But
starting
it's like-
to start.
No, you can go faster than that, Alex. You gotta
Yeah.
get it. You actually gotta have to get it turning.
There
Keep
we go.
going. That's a little bit more. There you go. let it start there for a minute and let's see what happens.
That was the speed that he started this last time.
Okay, now it's starting to see how the energy's transmitting outward now? Not very much, but it is.
You don't even watch. You can't really see it in there, but if you look at the building, it's shaking.
Yeah, the building is already shaking at the top.
2.0.
But you can't.
Okay, go up a little bit.
2.0.
Look, now the ground's moving. So if you were a person just this big, you'd be like, what's going on?
2.0 earthquake.
Oh my gosh, get out.
2.0 is really weird.
Get away from the building.
You'd be surprised.
Okay, now it's starting to build up that momentum. Okay.
3.0.
Yeah.
6.0.
Let's bring up to the 3.
3.0 earthquake.
Uh-oh.
Coming at you.
Now the building's in trouble. Oh!
Abby, you're supposed to catch
Okay,
it.
that's a good point. Basically at that line. Let's turn it down.
Crazy?
I know I can.
Let's
I
turn it
didn't
off.
see you do it.
Okay, now you guys can experiment with that. I'm gonna measure this and I'm going to you can try different weights and stuff if you want, but I'm going to use this as our base measurement, okay? Does that look like a good size for the building base?
Yeah, I like how it's circular and
You want a round building?
No, I mean like square. Like squarish.
Like a square circle? I know exactly what you're talking about.
like an average building would be, you know, like rectangular.
Did you see the
Rectangle,
skyscraper? Yeah. You see
Like that.
How about that? You like that building?
Just that.
Yeah, just
I can miniaturize
a
that.
smaller version, but
Smaller
a
version.
couple of them.
Okay.
Okay, well, see, now we
Does
can.
it matter if they're the same?
Now, how
No, it
small do you picture it? Let's do that.
I picture it more like up to here.
I picture it.
Now that's going to be a problem because now your weight is going to be a lot lower. So that means the center of gravity of the building is going to be lower and it's going to stand up better. I think you need some taller ones with some weight around
Maybe
the
we
top.
Okay, so
Maybe we can
right
have
about
some
here.
tiny ones.
But-
and bigger ones.
But Alex, you can cut this and you can
That's what we're going to
experiment.
do right now.
We're gonna experiment what would happen if we had a smaller.
And while you guys are doing that, I'm going to be working on the design for the building.
Okay.
Let me come around so I don't have my back to the
All right.
camera.
Come on around, Abby.
And I need you too, Will. All right, so Alex, how tall? Can you draw a line on it?
I was thinking about
You gotta take the cap off there.
anyway. I did that on purpose.
Okay.
Thinking more like this.
Right about there.
Yes. All around.
Okay, so let's go ahead and cut this down. Actually, let's use a razor knife.
Razor.
Can you take that off, Abby? Just tape on. There you go. All right.
Wait. Have you ever experimented?
All right, so we're gonna probably need more tape. Will you get the
Roll.
yep, a roll of tape, please?
Yes.
Because what's gonna happen is we're gonna get to the other side of this, and I don't know where the tape's gonna head out. Actually, looks like Uncle Mark's got it covered. Hey, no attention.
No one saw that. You were all blinking.
Okay.
There's our
That's really small.
model. Alright, we're done.
I
with
say you
our
need it skinnier and taller.
Okay.
and
We're still
taller.
gonna need that tape, but let's just hold.
Should we add the weight first?
I say we try it without the weight first as an experiment.
Okay.
Cause it's really
Because it's a
short.
lot shorter now.
Alright. Well, tell me when the wheel starts spinning.
Please.
Abby, I got it. You can go faster.
Now, have you ever tried to just go all the way fast, real fast, all the way up?
Yeah, that's what happened. Just
You did? Okay.
It just says
Is it spinning yet?
it stopped.
No, not
It
one.
was
Faster, faster.
I'll tell you when to stop.
That's pretty
Stop.
good, yeah.
Now let's get it going.
Okay, so while the kids
You
are
can go
working on
faster.
that with Aunt
This is
Trish,
like a
I
one-
will be working on
like
the
two
design and
bullets
SketchUp. This is the building that we used
I
from the
can
Quake
go
contest.
2.0. Are you on
But
2.0?
we will
Yes.
not be using that.
3.0.
That when it took out the taller building.
All right, so now the 3.0 and the taller building,
knock it over.
it fell right over.
Because I had a
This
wave.
is-
But yeah, that's true.
This is even.
So what do we think?
3.5.
So we think now, looking at this, it's not even really shaking too much, is it? I mean, it's moving the
It's good.
platform, but it's pretty stable.
It's good. Pretty good building.
All
Might
right, so
need a
let's
bigger
back it
building.
off and
Might
let's
need a
put.
bigger building.
Wow.
That's what I call resolver.
Cat-like reflexes.
That's what I call it.
That's so cool.
That's-
As soon as you told him to stop, it was like,
Mary,
I thought he was.
you're welcome to help.
Okay.
Come on.
Sydney should be dialed in. You want to say hi?
Hi, Sydney.
If you're on.
Sydney is our science.